Okay. That's good. Let me see that. Oh, what did I do? Yes, good morning, Z. Good to see you. Good morning, Arceus. Good morning, TWG. Welcome, welcome. Get to my moderator view over here. See how we're doing. All right. You're funny. That's pretty funny. Good to see you too. Hello, Reckless. Give everyone a chance here to hop in the stream before we get started today. There's a few things I need to do anyway, so let me pull up some stuff for that. If you guys have any questions about the assignment, I know plenty of you got started. I'm very happy about that. Please ask in the chat. There's a few things I will address before we start, though. Mainly, the question that was asked in the chat just before class started from Giaki, I think, which was about the average. So I'll talk about that. Other than that, everything should be good. All right, so it is 11:21. We don't have everybody, but that's okay. We can't always expect that. Hopefully they'll catch up on YouTube or they hop in here in the next 5 minutes. So the first thing I'm going to talk about is the assignment. I did upload some sample outputs, and it turns out my average function was not correct. I'll tell you exactly what I did. I forgot to initialize my average variable to 0. So what happened there was when I declared the variable, the average variable was initialized with some garbage value. So the compiler assigned that average value some address, and that address contained some non-zero value. So when I ran my sample outputs, I was averaging an incorrect, something that was incorrect. So after class, I will fix my sample outputs and I will re-upload them for you guys. And so that should be good. Other than that, we're going to kind of just move on with class. I know I didn't really get to go over everything in CS 135 that you guys learned, but for the most part, we covered a lot of it yesterday. So if you guys have any trouble with any of those functions for assignment 1, feel free to just send a message. I've been responding to you guys, and I always will when I can. In addition to that, today at 1 p.m. I'll have office hours, so you can come say hello if you'd like. I will say, if you would like to screen share your code, I'll probably do a private call with you just so other people can't just pop in that call and like watch over your shoulder, you know. So if I am not in that voice channel, just send me a message, and it probably means I'm in a call with somebody else, and I'll get to you as soon as I can. So now it's all said and done. I'm ready to get started with classes. So let me pull up the notes. We're gonna have a lot of notes today, but notes are the best thing for us, I think, to start with, so you have something to reference. Oh, and also let me show you. Let me just show you. This is the sample output here. You'll see that somewhere in here I type in 4. Well, that's not what I wanted. There's a whole lot of stuff in here. All right, here it says the average is 83. That's not correct. I will fix that. I will fix that. All right, so now I need a new one. That is not what I wanted. Can I have a fresh one, please? Thanks. Okay. So the first thing that we're going to talk about before classes, we're only going to take maybe 2-3 minutes to do it. We're going to talk about what a function overload is. Let me make this as big as I can so I have some room here. All right, there we go. So we're first going to talk about function overloading. Now this is a very simple concept, okay? If you guys know what functions are, you're going to be able to figure this out pretty easily. So, so far, what we've learned on how to call functions is usually we define a function prototype somewhere. And so when we call this function, you know, in main or in another function, how does the compiler know what function we're talking about? Does anyone have any guesses? There's an obvious one, which it's not a trick question, you know, I just kind of want to engage you a little bit. So how does the compiler or the runtime know which function we are talking about? Let's see if I got any water here. So there's an obvious one, the one that I'd hope that you guys know. Okay, well synchro, yeah, synchro is correct, and so is Z, right? So that's part of it. Okay, so the very first one, the obvious one, is the name. Okay, the name is the most obvious, but in addition to that, it looks at the parameters, the parameter list. So it's actually a combination. Hopefully you guys can see this. Please let me know if the text is not big enough. Should be done. So the first thing is the name, and the second thing is the parameter list. It's a combination. So thank you, Synchro. So what does this mean? Well, it means we can declare functions that have the same name but different parameter lists. And that is called a function overload. So this is called a function overload. Always remember it. This is a question I like to ask on tests. And so let's just do kind of an example of that. And my favorite one is always string concatenation. So how about we even just do a small program for fun, just so you guys can see it in action. It can't hurt. So it'll be fo.cpp. And let me pull it over here, and let's go ahead and get started with our most basic program stuff. So we always include our IO stream. We always use namespace std. And then in here we're going to have a main somewhere, and at the bottom I always like to return 0. All right, so now once we've done that, let's declare some functions. So if you recall yesterday, we talked about string concatenation, right? So this is kind of a goofy example, but we're going to use it in the sense that I'm going to make a function called plus. So we can have this function here. And in here, we can add maybe some ints. But then we can have a whole bunch more pluses. We could do an int float. We could do a float int. We could do float float. And we could do string string. Go away, IntelliSense. That's annoying. So notice here, these are all function overloads. These are the prototypes at least. And they all have the exact same name. So we're going to do just this example here. And maybe I want this one to return a float instead. Maybe I want this one to return a float instead. Maybe this one can return a float. And then this one, maybe we'll have it as an int. Okay? There are functions, so we can make them do whatever we want. So let's just give them some definitions down here. Some bodies. So in this one, it'll be super easy. We'll just return, I always like to do this, left-hand side, right-hand side. Now, you'll see that when we get to operators, but when I do something like 3 plus 5, there's an operand. That's called an operand on the left-hand side of the operator, and there's an operand on the right-hand side of the operator. So this is the left-hand side, and this is the right-hand side. So I'll do, that one's pretty simple. And in fact, we can do that with all of these, except for the last one. Now, I do want to add some couts in here, just so we can see it in action. And then this one, let's do something fun. I don't know, maybe we can do, I guess I have to give these names, huh? Here I am getting ahead of myself always. Always wonder what it must be like to watch me make mistakes and then just stare. I'm sure there's some of you who can't get it out of your mind. You just see that mistake sitting there. And you're like, I wonder if he'll ever notice it. And I'll always find it, hopefully. And in this one, let's return probably the lengths. Why not? Just for fun. These are strings, so let's just add the lengths together. Just like that. All right, so now we've got a bunch of function overloads, and now let's add some print statements just for fun to say that this is the int overload. And in here, we'll kind of replace them all. Like I said, I hate typing, so I'm just going to do some copy pasting. I learned last year that there's a fun trick. Let me see if I can remember it. In VS Code, if I hold left Alt, and I click on that, and I click on that, and then I type float, it replaces, I'm still newbie at that. It replaces it everywhere. Let me try that again. So if I hold left Alt, I click there, and if I hold left Alt and I click here, I should type floats, and it replaces both of them. So that's a fun trick. There we go. All right, so now we're just going to give these functions a try in main. So I'm going to make a few ints. Let's make int I1, which maybe can be equal to 5, and let's make an I2, which can be equal to maybe 10. We'll do some floats as well. F1, F2. And let's say that this one is equal to 3.14, and this one might be equal to negative 20.22. And then we'll do some strings. These should be floats. String S1. Now these are my cats. You've heard of loaf before. And we're also going to have Patty involved. Patty is also existing somewhere. She's actually up on that cat tree behind me right now. Maybe she'll come down and say hi eventually. So there we go. And so now we've got our parameters. And so let's kind of just call these, and you'll see what the execution looks like. So we'll say int maybe result1 is equal to plus, and we're going to pass in I1 and I2. I'm going to do 5 total calls, R2, R3, R4, R5. This is an int. This will be a float. Let me use my new trick here. And I can see here it's going to go down next to the 0. I can see where I messed up there, so I'll work on that. There we go. And let's see here. What are the operands? So maybe we'll pass in F1 here. Maybe we'll pass in F2 here. This one will be F1 and F2. And then these are going to be the strings. And I always like to add lines just so I can see what the heck is going on. And now we can give it a shot. So let's go into Bobby. We're already here. Wow. Her real name is Ophelia. I didn't give her that name. It came with her when I adopted her. But she is kind of just a little loaf. So thank you. Thank you for that. She's a Siamese, so she's got that bread color, you know? Let's see. I typed in F0, but it actually needs to be FO. And it looks like we have an error, and it's on something here. So let's go find it. I should always probably look at the line numbers, but maybe it's up here. Maybe I'll check the chat too. Maybe you saw my ridiculous mistake. What are you telling me? Expected on line 47, huh? What are you expecting on line 47? Oh, see? Silly mistake. As always. There we go. So now we'll compile it and we'll ./a.out. And you'll see that we called all of the appropriate functions. Let me see it here. And the compiler knew what to do. Let me see if I can put it here. I don't know if you can see it. Let's see. Yeah, roughly you can. So here it is, right? So these are the ints. You can see that it called it with the ints, and then it determined that this was int float, this one was float int, this one was float float, and then it called it with the strings. And we used all the same function name. Now, before we move on from this, pretty simple, right? I know this is a goofy example, and you guys are probably falling asleep right now, but I just kind of want to show you this. If I comment this out, just one of these, let me see it down here. Do you guys know about upcasting and downcasting? Kind of, did anyone ever talk to you about that stuff? 1, 2, 3. So we're gonna go 1, 2, 3. I don't want this one. There we go. Let's see if this one compiles and see what it says. Hey, there we go. Okay, so let's talk just a little bit about that, and then we'll talk about kind of what this error is telling us. So in kind of a general sense, numbers can be casted to different types. Now, I'm not sure if you guys have learned about bytes yet. Does anyone know how many bytes an integer is? 4 bytes, that's correct. That's 4 bytes. So we have a bunch of different number types in C++. Some of them are, for example, an int, which happens to be 4 bytes. A float is also 4 bytes. A double is 8 bytes. A short is 2 bytes. A car is 1 byte. Kind of tab it over here, make everything look nice and clean. Okay, so we have all these different number types, right? They all store numbers, but they're not stored exactly the same way. For example, a float is stored differently than an int is. And shorts and cars happen to be smaller than the 4 bytes of an int. So sometimes the compiler may decide that it's going to try to shove an int inside of a short. It may kind of truncate off some numbers. And sometimes it will downcast doubles into floats, and it may downcast floats into integers. So the downcast part refers to a larger byte size going into a smaller byte size. We'll also consider perhaps the float to an int. Though they have the same size, they are different data types. And then an upcast is the smaller byte size going into a larger byte size. Do any of you have any idea which one of these are safe? Is there, of downcast or upcast, is either one safe? See, Synchro asks, does that just give you an error? Now, sometimes it doesn't. Yeah, so Synchro and Arceus both say the upcast is safe, and that is true. And that's exactly why. You will never lose information when you upcast. If I can store a character in 1 byte, I can most definitely store it in 4 bytes without losing any information at all. So upcasts are generally safe, and the compiler may do this for us. The compiler may do it automatically. Now, the compiler may do a downcast automatically as well, but downcasts are generally not safe. Okay, so just as long as you know that the compiler will sometimes assume what it thinks you're doing, and it will try to compile it. Now, in the case of this, so let's look in main here. So specifically this one, I'm calling plus with a float and an integer. This is a float and an integer. Notice that I got rid of this one. So it can make a few choices, right? It says, all right, should I? So what do you think? What do you think this kind of cast is? If we're gonna take an int and shove it into a float, what kind of cast do you think that is? Obviously, they have the same amount of byte sizes, but floats and ints are stored differently. So you're going to consider that to be an upcast, huh? So I would say yes, but you know, it looks like I kind of made some errors in my notes. Now, let me tell you why. So floats have to save some bytes. Let's talk about this. Floats need to save bytes for the decimal. And so actually integers can represent a larger amount of numbers, a higher number range, a larger number range than a float. So I'm sorry that I misled you there. I'm sorry that I misled you. Well, so the upcast downcast part is kind of confusing in that they have the same amount of bytes. But because floats need to save bytes for the decimal, they can't store actually as many numbers as an int can. So let's see if we can do some Google magic here. And so if you do largest C++ value for float, let's see what C++ reference says. So this is the maximum integer value here. So the max int is this. Okay, so that's your maximum integer value, at least for 4 bytes. Now, float cannot store a number that large. So I'm really hoping I can find it. I'm sure we could calculate it if I wanted to. But you guys understand that the max float can actually represent this number. So in a sense, it's kind of a downcast. So I'm going to move this down here. Once again, I'm sorry for misleading you. I do make mistakes all the time. So float to an int is in a sense an upcast, except you truncate, right? There's a truncation error here. So in a way, not safe. In a way, not safe. Both are not safe. You guys know what it means to truncate, right? That means we chop off the decimal. So if we truncated 3.2, it would go to 3. 3.2 truncated is 3. Yeah. So either of these are not safe, and so the compiler is going to pick one. Okay? The compiler is going to pick one, but notice here it says ambiguous. The term ambiguous means that there's two things that mean the same thing. And so it's trying to pick between int, float, or float. It says, which one should I do? Well, in this case, it's going to try to shove a float into an int, which it considers to be not safe, but it might do it anyway. But then it also considers converting this into, let me see if I can pull it up here. So this is a float, right? So it considers making this one an int. It considers making this one a float and this one an int. Let me see if it's there. Yeah. And then it also considers making this one a float. So Ali asks, why wouldn't it default to float since it's safer? Well, I believe you're right, and I think it should do it. But the G++ compiler is not as smart as we hope it to be. And it just doesn't want to pick it. It says there's multiple options here. I'm not going to pick one. I'm just going to tell you that this is bad, and I want you to specify it for me. So a good way that we could force it to pick one is we can cast it. That should work. Yeah. And this is how we can kind of cast values to be a different data type. And if we do that, then we can probably get the compiler to pick the one that we want, which will be the safest one. Oh no, I made a mistake, didn't I? Yeah. Sorry, Ali, I actually confused myself. It's not a safe conversion, is it? Recall that the integer value might be larger than what can be stored in a float. So they're actually all considered kind of, which one's the safest? Let's see if we can figure it out. Well, they're all not safe. That's why, Ali. I apologize. Once again, making goober mistake, but they're all not safe. In this case, we're going to have a truncation. In this case, we'll have a truncation, and the int value might not fit inside of the float. And then here we'll have nothing happens here, right? But the integer value might not fit inside of the float. So actually, they're all not safe. And that's why it can't pick one. That's why it can't pick one. So I hope I was able to answer that question and I didn't confuse you too much. It's Wednesday. It's hump day. We're getting over the hump here. And it compiled that time. And look, it called the float because we told it which one we wanted it to do. All right, so I'll try to clean these up. Just remember that either is considered to be not safe by the compiler. And that's pretty much function overloading and a little bit of upcast, downcast. You'll get more upcast, downcast stuff when you get to programming languages, which is CS326, and compilers, which is CS460. Does anyone have any questions about function overloading? Please let me know. But now we're going to move on to the most fun part of our day, classes. And data abstraction. Let's see, where am I? Okay, here I am. So first we're going to start with a definition of object-oriented programming. Okay, something you've probably heard before. So the term object-oriented is it's a paradigm in a way. It's a programming paradigm. Roughly, or programming style. I'd probably go with style. Does anyone know of any languages that are completely 100% object-oriented programming languages? And is C++ a 100% object-oriented programming language? Z says Python. Ali says Java. I know for a fact that Java is correct. Java is a 100% object-oriented language. C# is a 100% object-oriented language. C# looks like that. I would say that C and C++, well, so C, I would say, is process-oriented. And C++ is C with classes. That's what some of the professors will tell you at UNLV. I would say C++ is an amalgam. I don't know if you've heard that term before, but that just means everything. C++ kind of has a little bit of everything in it. And so that's why I would call it an amalgam. And so we can take object-oriented approaches in C++. And the main thing about object-oriented programming is that we are packaging data and methods. Now I'm going to call them methods, but these are just another term for functions together into data types. So now I'm going to talk about data abstraction, because you'll hear this a lot. And what this is abstraction is a way to simplify data types. And the way that we do that is we will hide all of the features that the data type shares. And I'll give you some examples of this. So let me make sure I'm still in view here. Yep. So I ask you to consider just a generic car. Okay, I'm not a gearhead myself, so I apologize if I offend any of you with this example. But if you consider a generic car, there's a few things that we can assume about this. Well, we can assume that cars will have 4 wheels. We can assume that they'll have probably at least 1 door. Maybe some seats. Maybe a steering wheel. Perhaps they'll have pedals, right? So these are things that cars will probably all share. But what is different about cars? Well, we could consider probably the horsepower of a car or the engine that's inside it. That might be different. Is it a manual or an automatic? I don't think that this is too much of a difference nowadays. But I'll have you know I do drive a manual. I have a car from 2002. So, you know, still prevalent, maybe. What are the number of doors? Honestly, I could just keep going on, right? Is it gas? Is it electric? Does it have passenger seating? Is it a trunk or a hatchback? Did I spell this? These are flower petals, huh? I told you, I'm a computer scientist. Those are flower petals, right? You can always call me out, okay? I always want you to call me out. So, in this idea of cars, we can hide this stuff. So if we're going to make a car class, we don't really have to include these details that I've highlighted. And that simplifies our data type down, and we'll only consider what's different about the cars. Okay, so that's kind of a sense of what data abstraction is. We could consider another example with, say, birds. Birds all have wings, 2 feet, a beak, and eyes. But what are different about birds? Well, what's their top speed? Can they even fly? What do they eat? How big are they? What color are they? Things like this. You know, where do they live? So please let me know if you have any confusion on data abstraction, what I'm talking about when I mention data abstraction. So now we're going to talk about classes and structs. We're going back to the C++ part of this class. And we're going to start doing some coding, hopefully here pretty soon. So, do we already know about one of these things? Yes, we do. We have structs, right? Now, I'm going to ask you, have we used any classes before in C++? And if so, what do you think are some of them? Have we used anything from classes? Have we used any classes before in our programs? And can you give me some examples? Synchro says yes, right? So what do you think some of them are? I like to ask this question on a test as well. You can throw anything out there. I don't mind if you don't know, but you can take some wild guesses. TWG says I don't know, that's fine. Arceus says yes. Cherry is getting ahead of us here. Yeah, you're right. Cherry, you're right. Arceus says IF stream. That is correct. That's one of them. You nailed it. So let's put some notes here. We have used structs before. And then I ask, have we used classes? Yes, we have. What are they? Well, an IF stream is one. We also consider an OF stream to be one. Strings. Ali wants me to repeat something. Did I have a what's it called? Kind of a network problem? And do you want me to repeat these strings that I'm talking about? Please let me know. Or these classes, rather. Oh, the question is this. Have we used classes before, and what are they? Apologies for that. So, what's another one? Vectors. So you guys want to know a fun tip? I'll show you. Notice that this here in IntelliSense is green. And these are blue. So anything that's blue is considered kind of like just a basic data type to C++. The green things are classes. They're objects to classes. They're objects of classes. So strings are classes. If I bring in any vectors as well, you'll see sometimes it does it, sometimes it doesn't. If I say vector of int, vi, something like that, hopefully it will turn green for me. There it is. So this way you can always know if you're working with a class. Maybe it's a struct as well. Whoops. So when I ask you this question on a test, remember these three, okay? Remember these three. IF stream or OF stream, strings, and vectors. So Cherry got ahead of us here. And Cherry, I'll tell you how they're classes in just a moment. I will tell you exactly what a class is, and I'll explain that to you. Now, earlier, you said this. You said classes are private. So, what is the only difference between a struct and a class? Well, it's that classes are private access by default. Now, I'll talk about this. Structs are public access by default. And so now we're going to talk about what these are. What is an access modifier? An access modifier determines who or what can access members of the struct or class. So let's go ahead and get some code down here so I don't put you guys to sleep, so we can see what I'm talking about. So let me make my classes1.cpp here. Yes, I'm aware. And let me come over here and grab my favorite stuff. There you go. We don't need that today. And then we'll come down in here. Whoops. Hey, okay. That's fine. So when we're talking about structs, let's say, what kind of example are we going to want to work with today? Well, let me check my history here. Let me see kind of what I thought about. I've always done cars and boats. I've done shapes before. This one's my favorite. You might think this is boring, but point 2D, a two-dimensional point. There's no data type for that in C++, so we're going to make one. That's a nice, easy example. Now we're going to make a class. It's going to be the same thing, except that we now will add a C there on the end to prove that one of those is a struct and the other one is a class. So what are members? What are the members of these classes or structs? Well, the members happen to be the variables that are contained inside of the object, inside of the class or struct. So in this case, we're going to have an int x and an int y. And we're going to do the same thing in point2dc over here as well. So when we come down here in main, we can declare some of these types, right? So we're going to have the PS, that's going to be for point struct, and we're going to have the point2dc PC for politically correct. Just kidding. And if I want to set these values, if I want to set the values of the members, right, what do? I use the dot operator, and I say, hey, this might be equal to 3. And I say, hey, this might be equal to 4. Now let's do the same thing for our point class. There's a question here. I would like to address it. Let me just finish that up. So Arceus asks, these are our objects. Now that's correct. So these are the class definitions up here. This is a class definition. The objects are these. So right now we have 2 objects. As soon as I declare another one, we now have 3 objects. We now have 4 objects. Does that make sense? This is going to be object number 1, object number 2, object number 3, object number 4. If that's confusing to anybody, please let me know. Thank you, thank you. So, we would expect this to compile, right? We would expect this to compile, but it's not going to compile. And it comes down to this thing we were talking about, how classes are private by default and structs are public by default. So let's make our compiler error happen, and we'll talk about what it says. Hopefully I can kind of drive it home here what this means. And of course I'll provide some definitions for you so you know what it means. So I called this file classes1.cpp. All right, and so now we're getting our compiler error. So notice here it's all on politically correct, right? PC point class. It's on the class point 2DC. And notice it says that X here is private within this context. Once again, it's saying that it's declared private here. And so what does this mean? Well, if something is private, it says only I can access this member. And so Arceus is correct. If we wanted to access it, we could come up here and we could say, hey, if you are public, and I'll talk about how this thing works in just a moment, but if I declare these to be public, if I save the same file, and then I load it back up to Bobby here, and I try to compile it again, it'll work. It works. So let's talk about what these things mean. So what is an access modifier? It's either going to be all the time public, private, or protected. Now we'll get into protected later. Perhaps on Friday or perhaps Monday next week. For now, we're only going to talk about public and private. So I'm actually going to do a copy paste here. I hope you don't mind, but we'll kind of just read about it here. So these are our access modifiers. A public member is a member that is accessible to all things, no matter where you are. Okay, so notice here in the struct, it's public by default, and these guys happen to be public now too. And notice that we're in main, and so we say, hey, main has access to this stuff, we're public. You can change me if you want. You can access me, I don't mind. Now, private members, this is only accessible to the class. So any function in the class can access these members, okay? So we haven't really talked about the function part yet. We're getting there. But when these are private, for example, as I said before, when these are private, main is trying to access them, and the class says, or the compiler says rather, this is not class .2dc. This is main. Main does not have access to these variables, so I'm not going to let you touch them. This is a safety thing, and it makes, so in the real world, a lot of people will be working with the same code. If you can make things private, you can prevent people from messing up the code, basically. you can prevent people from messing up the code. So in a way, the private variables, we kind of hide them. The public stuff, we'll show them. And then I'll just mention this, a protected member, I said it's for next week, but this is an inheritance thing, and it's accessible to the class and the derived class. So don't memorize that one yet, but we'll come back to it. And so now I will show you an example of a public member function. So these are private by default in the class. I will always specify them as private anyway. I will tell you how they work. Any member listed underneath an access modifier belongs to that access modifier. Belongs to that access modifier. So in this case, X and Y are listed underneath private, so they belong to private. The moment I come down here and say public, I now can list members that will be public. So let's do something called, how about set X? How about we make a function that can set the value of this variable? So this function won't have to return anything, okay? So I'm going to make it a void type. I'm going to say set xy. And it will take two parameters. Let's say it's x1, and let's say it's x2. Or y1. Getting ahead of myself here. So notice that the private members here, they're still private, but we made a public function. Now this class, or this function here, it belongs to this class. So in fact, set xy will have access to these variables. So we could do something like x is equal to x1, and I could say something like y is equal to y1. Now, what's the point of doing this, right? We basically accessing the members as before. Does anyone have any ideas of... Well, let me just ask you. This is not a very specific question, so I'll only wait a few seconds. But there's some extra things in here that we can do, right? By keeping these private, we could add some more code within this function, right, to prevent some things. So Cherry asks, you don't change the variable itself. Well, we'll do it right here. So this x will be the same as this x. But kind of what I was getting at is I could do some error checking in here. I could say, hey, what if this is a positive 0.2D? It only exists within the first quadrant of our graph. So any negative values, I could prevent the negative values from going inside that x and y. So I could say if x1 is less than 0, or y1 is less than 0, see out, I will not allow this. And I don't do anything. But else, I could say, yep, you're good. You are both positive. And you can go in there. So notice that we're kind of wrapping up our our private members in kind of a safety blanket. So by providing this public member function, we can control exactly how people manipulate, or exactly how other functions will manipulate our members here. So instead of doing this, we might do pc dot. Notice that it pops up here in IntelliSense. That means that IntelliSense knows that it's public, right? It knows that it's public. And so we're allowed to call it. Now this should start looking like some of the stuff we've seen before with strings. TWG says, I'm confused. What can I help you with? What can I help you with? I'll wait. I'll slow down. I know that this is kind of, this is some brand new stuff going on here. Let's see if we can help you understand what I'm talking about here. I am going to put these two parts in here, though, while we wait. So you ask, how are X and Y able to change? So yeah, let's kind of start over here just a little bit. So this is class point2D, and so every object of point2D will have an X and Y variable. So every object of this class will have an X and Y variable. So this one here has its own X and Y, but they are listed as private members, okay? They're private. And so if we go look at our notes here, we'll see that private members are only accessible to the class. Anything that's a part of the class can access those X and Y variables. So notice here we do have a public function, but this function does belong to point2DC. setXY is a function that belongs to point2DC. So in a sense, this function is the class. This is a function that belongs to the class, and so this function will have access to anything that's private within point2DC. Once again, private members are only accessible to the class, and because setXY is the class, it is allowed to access these member variables. Main, however, is not a part of the class, so it will not have access to these member variables. Was I able to clear up a little bit of confusion with that? Yes, so TWG says, in a way, I have opened up these private fields by declaring a public function, and I'm letting them see the light of day, right? But look, I kind of have some error checking in here, right? So they can only kind of see the light of day. Yeah, no problem. Always stop me. I know I get excited and I go fast. You need to slow me down all the time. Z says, you always need to declare a function to access the variables. Yes. In a sense, yes. If these are private, you are going to need some kind of function to manipulate them. Almost always. Almost always. So in this sense, we've made this, right? And I say, hey, I only want positive values for my X and Y. So I don't have direct access to these variables, right? I kind of have this safety blanket here. And so every time I call setXY, sure, I can pass in whatever values I want, but it's going to say, no, if these are negative, I'm not going to allow this. These are my private variables, and you can't do this to them. But if I leave these as positive values, it will say, all right, I'll let you touch them. So let's try a few examples here. We'll do pc.setXY. The first one will work, but as soon as we pass in a -1 and a -3, it's going to say, hey, no, that is totally not allowed. Whoops. So let's go run this on Bobby, see what we get. And everyone is, yeah, exactly. TWG says, access but with a set of conditions. Exactly. And it's completely up to us. What do we want to do? What do we want to enforce? That's completely up to us. We don't have to enforce anything if we don't want to. So notice here, the first time we set the values, it goes through, right? It goes through. It says, yeah, that's great. But then the second time I pass in some negative values. And here we see the print message saying, I will not allow this. You are not allowed to do that to my private variables. So oftentimes you'll see getters. So is that the next thing I talk about? Let's see. We'll talk about a getter. There's a few things I kind of want to throw in here. I maybe just kind of skipped over them a little bit. Let's see here. I've got a lot of notes going on here. So I'm going to throw a little bit, not yet. We're not going to get there yet. So I'm going to add this to our notes here. I kind of talked about what a member was, right? We all know what a member is, so that's kind of coming up next here. But I'm giving you an example of just kind of what we did in the code. Okay, so notice we've got these private members, and I'm actually going to add these functions here. I won't talk about what we call these yet, but guess what's super nice about these? So let me just ask you this. I just want to check in on your knowledge. If I put an and here, does anyone know what that does? It is similar to pass by reference. It's similar, but it's not quite the same. Almost, right? It's a return. It's like a return by reference. Yeah. Almost. We'll get more into this later, okay? So we won't talk about this. But this means that it will actually return the memory of Y or X. Now, since these are private, we should get a compiler error when we do that. But in general, our functions look like that, right? And so what does this mean? That means we're going to make a copy of X and then return it. So if we want to access X, but we don't want to access the exact X, these return copies. So oftentimes you'll see these kind of things where I want to see what they are. And so I'll say, hey, what kind of values are we looking at? Well, let's get the X and let's get the Y. So I will run this just to show you that it works. Now those are really simple functions. You'll see that a lot. Oftentimes in your assignments, I'll make you put these. We call these getters. And like I said, I'll get into them a little bit later. But it's just a very simple function that returns a copy of whatever the private variable will be. So there you can see, we tried to set the values to be negative values, said I will not allow this, and the values are still equal to 2 and 1. So please stop me if you are confused at this point, because we are about to move on kind of past these private public things. Now this is not the end you'll see of them. You'll see them every day from here on out until the end of the semester. So if you don't quite understand them yet, it's okay, because we're going to really hammer it into your head what these things are. But it's time for us to move on to the next thing about classes. So I'm going to save this as classes 1, but then I'm also going to make a copy of this same code so I can continue off of it. So if you ever want to come back and look at the first thing we did, we're going to have 2 different files for that. So now I'm going to talk about constructors. Has anyone heard the term constructor before? You don't have to tell me what it is yet. I just want to know a yes or a no. I'm sure some of you have. So let me add some definitions in here. I'm seeing some yeses. That makes me happy. That makes me happy. So we talked about what members are, right? I'm kind of leading up to constructors here. So we talked about what members are, so I'm adding that to the code, or to the notes. And then I give a nice little example of that here, where we've got a car and it has a member for the number of wheels. Okay, so you'll see that in the notes. And then I ask a question. Can we initialize? Now it's time to type. Can we initialize the members of a class? So you might say yes, right? You might say yes, in which as soon as I declare this, I say, don't forget to initialize it. Let me get rid of this struct. I'm not interested in using it anymore. I don't want this to be a C anymore. Say goodbye. You can be just P now. Say goodbye. We don't need you. And we can get rid of all these C's. You're no longer politically correct. Rather, you're just a point. Okay. So here is this object. We just declared it. RIP struct. Yeah, we'll miss you. You will be missed. And now I want to initialize it, right? I'll be like, don't forget to initialize. Please. So I'll be like, I got to set these values. Don't forget to set them. But can we... You guys make me laugh. Can we make it so that they're initialized automatically right off the bat? We don't even have to think twice about it. As soon as I open this out of its little variable box, can I guarantee that there's going to be some values in there already that I don't have to worry about? And that's where the constructor comes in. That's where the constructor comes in. So now we're going to talk about constructors. So I will explain this, but for those of you who have heard of constructors before, do you know when the constructor is called? And if so, when? When is the constructor called? Let's see, where's my constructor stuff? Here it is. So Cherry says, as soon as the class variable is created in main. That is 100% correct. As soon as I declare this value here, as soon as this comes into the world, it's born, constructor is called. Constructor is not called, constructor is called. As soon as that variable is declared, as soon as that variable, like I said, it's born, we call a constructor. We call a constructor. So we'll say, hey, well, first we'll start like this. Constructors are kind of like functions. Except they don't return anything. They don't return a type. Wow. Yeah, I have to be careful with what I say here. They kind of return an object of the class. It's only called when an object is declared or allocated in terms of dynamic memory. We'll get to that. But these are kind of static. We're not going to get into that yet. So for now, we're just sticking with the declared part. Next week, we'll get into this allocation thing. And so now we have some fun example here. I'm just going to copy it in here, but then I'm going to go into the code and talk about it a little bit. So let's forget about our points for a little bit, and let's come back to the string. As soon as we declare string s. So here, this is what's called our default constructor. And thanks to the default constructor of a string, you can always assume that it will be empty when it comes to life. Now, have you ever seen this before? Likely some of you may have not seen that before, but this is also a constructor. This is not the default constructor, but this is a constructor. This is a parameter constructor, we will call. And what does it do? It initializes the string to loaf. So we're going to go ahead and make some constructors for our point2d, and we're going to talk about them. So I always like to put my constructors right underneath the public, and my member functions will be down here. And so a constructor is always the name of the class. We always need to remember that. Constructors are always the name of the class. So we'll hop in here and we'll say, hey, this is a point2d. This is our default constructor. So whenever I want a point2d to come to life, I'm going to say, hello world. And in addition to that, I'm going to say, hey, x is equal to y, which is equal to 0. Does that confuse anybody? If you haven't seen that before, that's the same thing as x is equal to 0 and y is equal to 0. They do the same thing. Here I'm going to initialize my variables. Initialize private members, rather. So let's practice with this. Let's practice with this. So before I set any of the values, let me call p, let me do this print statement here. Let me see what the values are equal to. You guys following along so far, right? Things are kind of making sense. You're not asleep yet. We are coming up here on the end of class. We've got about 18 minutes left, so hopefully you can hang in there. Let's ./a.out this bad boy, and here you go. Look at that. Look at that. So let's do some fun examples. So let's talk about in the code here. So the very first thing you see is hello world. What's the very first thing that happens in main? We declare a point2dp. I want to make sure that you guys can see this on the screen. Yeah, that looks good. Right, okay. So that's the very first thing that happens in main. And so that's when our default constructor is called. And so I'll have you know that if there's no default constructor assigned, let's do this. If there's not a default constructor defined, the compiler will always make one. So before, you didn't see this hello world thing, right? And that's because we hadn't defined a constructor for our class yet. So the compiler made its own, and it said, you don't really have to do anything. Just make this thing come to life. Now I went up here and I said, hey, this is a constructor. Notice it's the default constructor. The default constructor doesn't take any parameters. Let me make sure we know that. So the default constructor is not taking any parameters. And so here I've specified it. And I said, now that you have a constructor, I want you to do this code. I want you to do this code. So the code that it does is it prints hello world, and then it initializes these values to be 0. And so it prints hello world, and then it initializes the values to be 0, and then the very next thing I do is I print them out. And I say, hey, look, they're 0, 0. So now we're going to make another constructor. Just kind of like I did with the string before. I'll show you the same thing with this. So let's say I make a parameter constructor now. This parameter constructor is going to take some values. Kind of like the same as set x here. We're going to call this one the parameter constructor, as I said. Constructor. And in here, I'm going to see out param constructor. We'll kind of change this up there a little bit. Cherry asks, there's a function called getX. That's correct. Here it is. And you'll notice that I'm calling it right here. Right? It's right here at the bottom. Kind of hard to see with my giant code. But yes, it's there. So this is going to be the param constructor. Let's call this the default constructor instead, so we can see which ones are being called. And guess what? I could say x is equal to x1 and y is equal to y1. But look, I have this fun function here. So I'm just going to call set xy. So now I'm actually going to ask you guys a very important question. I'm going to ask you a very important question. Why up here am I allowed to call it like this, but in main I have to call it with an object? This is a hard concept to understand. So I want to address it now while we're fresh into this class stuff. Should we take a breather and everyone hit a little refresh? I'm going to hit a refresh on my stream here. And we'll take a little bit of time here. All right, so we have some answers. I'm going to kind of read them here. So Ali says main isn't in the class and it's private. I would say almost. The main part of it is important. Cherry says to access the class function in main. That is correct. I would say synchro is the closest, in that in main you have to declare an object for it. So let's think about it like this. This is just kind of a definition, right? M Gisto here says you call the class members like a struct. That is correct. M Gisto, if you don't mind, let me show you up here that structs and classes are almost exactly the same, except that this member access thing is only a little different. So structs and classes, pretty much they're identical. So to answer your question, yes. Anything you do in a struct, you can do in a class, pretty much. So up here, as I'm saying, this is a definition. So when we're basically making a skeleton. So if I made a class for a human, I would make like I don't like that example. Let's say I made a class for a building. This is the blueprint for the building. This here is the blueprint for our two-dimensional point. And once we have the blueprint, we can then spawn a whole bunch of them. I can say, hey, C, D, E, F. Boom, now we have 5 objects. We have 5 objects. And we use the same blueprint to create every single one of them. Now, every single one of these objects has their own X and Y. They have their own X and Y. So a PX, we can't access it, okay? We can't access it yet. But a PX is different from a C.X, okay? C is a different object from P, so their X's are different. And so when we're outside of the scope of the class, we are required to tell main, I guess in this case, which object we're going to. And I want you to talk about the X that's in P. I want you to talk about the X that's in C. I want you to talk about the set XY that's in P. Stuff like that. But when we're in the blueprint, we always know that we're talking about, this is kind of terrible English, but we're going to use it, the this object. This is the blueprint. So I can access X and Y without referencing an object because I'm already assuming that I will be inside of that object. So I can call set XY here because I know that whenever, for example, I know I'm probably not making much sense here, but I hope I'm kind of getting through to some people here. Let's say I want to initialize these values to be 7, 2, 7. This is where we call our parameter constructor. So kind of think about it like this. Here, I did this wrong. Here I declare a point P2, and I call the parameter constructor. And so what it does is it goes up to the blueprint. Remember that we're in P2 right now. So it calls the parameter constructor for P2. It comes up here, it says this is the blueprint for that. And then it comes down here and it says, hey, you want me to call set XY? Well, I know that I'm already in P2, so I'm just going to call set XY. Synchro said O, so I hope that means something. TWG says you can only make and change copies of the original. In a way, yeah. Recall that this is just the blueprint. So the blueprint actually isn't an object. It's kind of just in the sky, right? It's kind of like a piece of paper that the compiler will reference whenever creating a new object. But then when you go into main, you actually make objects of that blueprint. And if you're inside the blueprint, you don't have to specify which object because it's the blueprint, right? But when you're inside main and you're actually working with the objects, you need to specify which object you're working with. So this is going to take some practice. Tomorrow you'll get a new homework assignment. Not today, but tomorrow. And you'll have a chance to work with this, okay? You'll have a chance to work with this. So if you're still a little confused, don't worry. We're going to spend plenty of time with classes, I assure you. So back to the main point I was making is that this is our parameter constructor here. And notice that I'm just going to call set XY. And what does that do? Well, it's going to set X and Y for us. I could even do it here. You guys might prefer it this way. And let's see kind of what happened here. Arceus asks, are both assignments due Saturday? The classes assignment will be due later next week. I'm always going to try to give you a week to do it. At some point, I'm going to have to speed it up And when that happens, I'll give you a tiny assignment so that you can kind of hammer it out in just a few days. And then the final project, I'm going to give you a full week for. So at some point, we'll have to speed it up. But right now, we're just going to give you guys at least a week or 6 days to do your assignments. So let's compile this and let's run it. And then maybe we will double check our notes and maybe we can take a breather for the day. Before I talk about that, I just kind of want to print some stuff here. And we don't need to do this part anymore, I think. I think we covered what that does in the original example, and you'll have access to that. So I do want to just move classes 2 onto here so we have a nice clean output. All right. Let me check. So let's just take a look here again at our stuff. My screen is so big that I can't grab this, but we did it anyway. No, that's not what I wanted. All right, and let me see if I can angle this in such a way that you can just see just barely what's going on. Yeah, that looks good. So notice here, this is just the P that we called with no parameters, 0 parameters at all. So which one did it call? It called the default constructor. What does the default constructor do? Well, it prints default constructor, and it sets x and y to be 0. Next, we created a new object, P2. Now, P2 was called with parameters, 2 and 7. And so it says, which constructor am I talking about? This kind of comes back around to the function overload idea, right? Here we have 2 functions, right? Constructors, rather, that have the same name, but it's going to look at the parameter list. Here it calls it with a 2 and a 7. And so it says, this is the parameter constructor. What do? Well, I go up here. I print out parameter constructor. You can see that happened over there. And then it sets x and y to be the parameters. Finally, we come down here and we print out what P is. P happens to be 0, 0 because it was called with the default constructor. And P2 happens to be 2, 7 because we called the parameter constructor with 2, 7. And we printed them out. Notice that when we call getX on P, it's different from getX on the P2 because they're different x's. And that's my spiel for the day. So tomorrow we're going to continue on trucking through this. I think we got a good start. I hope that you guys have some idea of what's going on. If you have some questions, feel free to type them out now. I'll hang out with you for 5 minutes or so. But if you're happy for the day, you are welcome to go. I hope you have a great rest of your Wednesday. And I have office hours at 1, so if you want to come chat, let me know. Cherry asks, will any of the books you put in the syllabus give problems, whereas I can try to practice classes and code it? Yes, how about I go look for that right now? Let's see if we can find it while you're here. Oh, this is the wrong one, folks. Don't look. It's the wrong one. Did I name this Fall 2020? I have to fix that. That's silly of me. Let's go look at this book here and let's see if we can find anything. All right, so it looks like this is a whole C++ book, so you'll find everything in here. Standard C++ classes, custom objects. All right, so if we go to page 430, approximately, plus a few. No, that's not what I wanted at all. Why'd you do that? All right, go there. Oh, man. Can I enter somewhere? So yes, to answer your question, Cherry, it is. It's roughly on page 430. I see exercises. I just want to go look at it. And so maybe I can get there. Oh, it's working now. I guess I just have to like click on it in the correct spot. There's some stuff about constructors here. There's stuff about that. Exercises. Give a definition for a simple rational number. Yes, so go to that page, okay? Ali asks, will office hours be through video chat, call, or just answer questions? Whatever you want. You can come talk to me in that chat. If you want to do like a code sharing thing, we'll do a private call and video chat. But if you just want to send me messages, I know some of you don't like, some of you may be introverted like me, and I hate phone calls and stuff too, so whatever you're comfortable with, I'm comfortable with. Cherry asks that you won't be considered for plagiarism if you copied sort functions from CS135. No, I don't mind that at all. Sorting functions, there's a ton of them out there, but there's only a few. So I usually use bubble sort in this class all the time, and I code it exactly the same way as I did in CS135. So you'll be okay. In RCSS, you can reuse code if it's your own. I think that's 100% completely okay, yes. Go back to 135, look in those files, copy code in. I think that's totally great. Whoa. So, yeah, thank you. If anyone else has any questions, just message me or come to office hours. And that's what I got for you today. So I will upload this to YouTube. I'll post all the notes, and I will see you tomorrow. Thank you for coming to class. You guys make my day. Happy Wednesday. Goodbye.